Good morning, all of you. Today, wait. Today we are going to start our second chapter. Second chapter is the solution. Now, see. In common sense, what is the solution? Solution is simply mixing of two substances. Okay, solution mix means the mixing of two substances. Now, how we are mixing, or in what proportion we are going to mix? This is the main concept of solution. Solution, in definition, solution means the homogeneous mixture of two or more substances is known as the solution. Now, where one is solvent and that is solute part. This one is solute, this one is solvent, and which gives us the solution. You well know about this. The solute present in small amount and the solvent is large amount, which makes the solution. Suppose salt solution. Salt. Sodium chloride is salt plus water gets solution of NaCl. We will get solution of NaCl. How? Sodium chloride, that means solute, this one, solvent, this one, solution. Okay, therefore solute dissolve in solvent. Okay, there are different types of solution. See one by one. The types of solution is the first type is the gaseous solution. This is the gaseous solution. Now see, if the solute is gas and solvent is also gas, then the mixture has example something, an example of mixture of oxygen and nitrogen. Okay, mixture of oxygen and nitrogen. If the solute is liquid and solvent is gas, then the solution, suppose example, chloroform mixed with nitrogen gas. If the solute is solid and solvent is gas, it has the example of camphor in nitrogen gas. Camphor means one kind of solid substance, okay, which is organic and which can be found from our petroleum. Next is liquid solution. Liquid solution, if the solute is gas and solvent is liquid, then the solution is called liquid solution. See, O2 dissolve in water is an example. Second is liquid, ethanol dissolve in water. Is solid liquid, glucose dissolve in water, simply. Next is solid solution. See, when the solute is gas and solvent is solid, then we have the example solution of hydrogen gas in lead. Lead is solid, this is gas. Liquid is a solute and the solvent is solid. Then amalgam of mercury and sodium. Sodium is solid, you know. This mercury is a liquid. Okay. Next, if both the solid and solvent are solid, then one example you can say copper dissolve in gold. That means AU. Copper dissolve in gold. Okay. Next is the main important topic, how we express what concentration of solution we prepared, or what is the solution, what is the concentration of the solution. Now, one method is the mass percentage. With the help of this mass percentage and some other points we'll study, by these points or by this concept, we can say the how percentage or how strength or what is the strength of our solution. See, first is the mass percentage of compound. Mass percentage means W by W. W is the weight, W is the another weight. Okay. Now, mass percentage of component is equal to the mass of the component in solution. Mass of the component in solution total mass of the solute into 100. This mass of the component means mass of the solute in solution, and the total mass of the solution means the solvent plus solute into 100%. Okay, next see, next is the volume percentage. Volume percentage, V by V, that means both solute and solvent are in volume, that means ml. Say volume percentage of component is volume of the component by total volume of the solution. This volume of the component means volume of the solute. Total volume of the solution means volume of the solute plus volume of the solvent into 100. Mass by volume percent. Mass by volume percent means the solute is in mass, that means in gram, and the solution is in volume, that means ml. See how mass by volume percentage of a substance in solution equal to mass of the substance in solution, that means in gram, mass of the solute in solution, and total volume of the solution into 100%. Next is one of the important is the ppm, which is parts per million, in ppm, number of parts of the component means here solute, total number of parts of all compounds in the solution, okay, into 10 to the power 6, that's why it is parts per million, okay, 10 to the power 6. Next, one of the most important is that mole fraction. See, what is the mole fraction? Is defined as the ratio of number of moles of component in the total number of moles of all the components present in the solution. Suppose see, we can explain then with an example. See, in a binary mixture of two components A and B, suppose A is the reactant, B is the another reactant, or you can say A is the one component, B is the another component, having their number of moles is Na and Nb respectively, then the moles fraction of A, this one is not X, this one is xi, okay, xi A, that means mole fraction of A is equal to the mole fraction or number of moles of A divided by number of moles of both the component. That's why here Na and Nb. Therefore, mole fraction of B is similarly X xi B equal to Nb. That means number of moles of B divided by number of moles of Na and Nb. Remember one thing, if you just add xi A and xi B, we will get 1. That's why here is written xi A plus xi B equal to 1. Okay. Now, here two important point is there. See, number of moles of any substance, that means in a reaction how many number of moles is reacting or reacts, okay, N, which is defined as N, is given by given mass, that means suppose 4 gram 5 gram is dissolved in 100 ml of water, is the given mass, and the molar mass. Given mass is we are using the mass to prepare a particular solution, okay, and the molar mass is the molecular mass of the component, which is based on the molecule. Therefore, N divided by W by M. W is the given mass and M is the molecular mass, and small n is the number of mole. Okay. Next, the molality. Okay, molality. As you know in from class 11, what is the molality, normality, and molarity? Okay, we'll just go through once again. Molarity. It is defined as the moles of solute present in 1 liter of the solution. Remember, 1 liter of the solution. That's why it's molality. Sorry, molarity. Molarity is the in 1 kg of the solvent. Okay. Molarity is defined as the number of moles of a solute present in 1 liter of solution. Therefore, molarity M, capital M, is the number of moles of solute divided by volume of the solution in 1 ml. 1 liter. Now what is the working formula? How can I calculate the molarity of a given solution? See, molarity M equal to given mass of the solute W2 into 1000 divided by molar mass of the solute M2 by volume of the solution in ml. That means in what volume we are going to make the solution. Suppose it is 250 ml, suppose it is 500 ml, because our standard measuring flux, that means volumetric flux, we can obtain in 100, 250, 500 or 1 liter. Okay. Next is the molality, Lity, molality. Okay. Molality defined as by small m. It is defined as the number of moles of solute dissolved in 1 kg of solvency. 1 kg here, but here is 1 liter. Rest are same. See, molality is defined as the number of moles of solute by mass of the solvent in kg. You have to convert or you have to use in kg, not in ml. How is the working formula? Working formula is same as the molarity. Molarity M is W2 by 1000 by M2 into mass of the solvent in just kg. Okay. Next is the normality. Normality is the most important. Normality it is defined as the number of gram equivalent of the solute dissolved in 1000 ml of the solvent. Here is the gram equivalent. One new word is there, gram equivalent. Now what is gram equivalent? Okay, equivalent or gram equivalent mass of a substance is defined as the molecular mass of a substance divided by n. N means acidity or basicity. Okay, and the working formula of normality is the weight of the solute with W2 into 1000 by equivalent mass of the solute into volume of the solvent in ml. Okay. Now see, how can you calculate this N, acidity or basicity? Okay. Now see, suppose HCl, we are giving example or we are preparing solution of HCl. HCl is, here is plus, here is minus, that means here acidity is 1. Similarly, suppose H2SO4 sulfuric acid, here 2 positive, that means 2H2, 2H negative, that means here acidity is 2. Suppose base is suppose NaOH, here is positive, here basicity is 1. Similarly, suppose for potassium permanganate, here the basicity is 5. In suppose potassium dichromate, here also 5. Okay, you have to remember some acidity or basicity to prepare solution in our laboratory. Next, molarity of a substance depend on temperature, since volume depends on temperature. Which rises in temperature, molarity decreases. See, molarity actually depends on temperature. Okay, because it is related with volume. If we raises the temperature or we give the heat of a solution, its volume may increase. Temperature, its molarity decrease. Okay, but molality do not depend on the temperature because it does not relate with the temperature. Okay, here is a simple one, numerical is there. Calculate the mole fraction of benzene in solution containing 30% of mass on carbon tetrachloride. 30% of W by W benzene, that means 30% of benzene containing in how much? 70 gram of the carbon tetrachloride. 30% of benzene carbon tetrachloride means 30 gram of benzene is present in 100 gram of solution. 100 gram of solution, remember, not the any solvent or solute. Mix up of solvent and solute. Therefore, mass of the carbon tetrachloride is 100 minus 30 gram, 70 gram. That means to prepare 30% of benzene in carbon tetrachloride solution, we have to add 30 gram of benzene in 70 gram of carbon tetrachloride. See, now molar mass of benzene is 78 gram per mole. You know, the molar mass of carbon tetrachloride is 154 gram per mole. Therefore, number of moles of benzene given mass by molar mass, how many moles of the benzene is given? 30 by 78, This one is given mass, we have given to make 30% of solution, but it one is molecular mass of benzene. We will get 15 by 39. Okay. Now, number of moles of common tetrachloride, similarly 70 by 154. 70 is the gram of common tetrachloride, and the 154 is the molar mass of common tetrachloride. We will get 5 by 11. Therefore, mole fraction of benzene C6H6 is NC6H6 by NCCH6 plus CCl4. Remember, this one is the solute plus solvent, that means solution. Now, if we calculate, if we put the values of this one and this one, we will get 0.9. Get 0.9. Therefore, mole fraction of common tetrachloride is 1 minus mole fraction of the benzene. That's why 1 minus 0.9 is 0.1. Okay. Thank you.